Okay, YouTube, in this video we're going to continue to explore graphs of linear equations, and what we're going to focus on really is writing the equation of a line or a linear equation in two variables x and y. And so in order to do this, what we're going to do is we're going to develop what we call the point slope form of the equation of a line that allows us to typically always write the equation of a line, but it involves the base definition of slope in the first place here. And so let's go ahead and take a look at this and how we could modify this to represent the equation of a line. But we say that if x1, y1 is going to be a point on the line, on a line. Okay, so we would say that there's some point x1, y1, and that's on a line of slope m. And so we would have this line right here that I could guarantee that as long as xy is any other point on the line, I could tell you that the slope is m over 1, or it's got a slope of m. Then we could say that this must be true, or in other words, we could say that the slope m is equal to the change in y values here over the change in x values. So you see y minus y1, x minus x1. This would be our slope. Well, what we're going to do is we're going to leave this second point here general, which means we're not actually going to pick a point for it. It's just going to be x and y. But so long as we have a point, x1, y1, and a slope, then this would be a good thing, because what we could do is we could take both sides of this quantity here, x times x minus x1. And what that's going to do is it actually essentially wipes out the denominator over here. And what we get left with is this equation involving both of the same variables x and y, but written in this form, y minus y1 equals m times x minus x1. And this is what we're going to refer to as the point slope form of the equation of this line. And so with respect to what this is, this point slope form, really essentially it gets its name because we need two things in order to write the equation of a line in point slope form. But we say that the equation of a line with slope m, okay, passing through the point x1, y1 is given thusly. So the three values that we're always going to need to know in order to write the equation of a line are the slope and a point on that line. So we have needs to write a linear equation. Okay, you can make yours look nicer on your paper there. I'm just trying to get this down here. One, we need the slope. That's kind of a biggie. And then two, we need any point on the line. That's it. So that being said, let's go ahead and take a look at an example here that I've got listed of how we could do this, and also how to rewrite it into slope-intercept form. So notice it says we want to find the slope-intercept form of the equation of this line, which would be our y equals mx plus b form. But we notice that the line has a slope of 3, and it passes through the point 1 comma negative 2. So a couple things I'm going to write here. First of all, I'm going to write that our slope is 3. We already know the slope, and we actually already know a point. We're going to call this point P. We'll say is 1 comma negative 2. So just to kind of give you a visual here before I actually go and write this equation here, we know that this graph goes through 1 comma negative 2, which is certainly this point right here, 1 comma negative 2. And we also know that the slope is 3. So 3, or 3 over 1, is going to rise 3 every time it runs 1. Rises 3 every time it runs 1. Rises 3 every time it runs 1. And this just continues to happen. We go back 1, down 3 even, and look at it this way. But what we want to do is write the slope-intercept form of the equation of this line. Now, in this particular instance, it'd be pretty easy to do because we already know the m. And as a matter of fact, it looks like the b here is at a height of negative 5. So we could go ahead and do that. But again, the idea here is that I want to show you how can we use the point slope form of an equation of a line. So the point slope form, let's get used to this, is y minus y1 slope times x minus x1. What we're going to do is we're essentially just going to plug in x1, y1, and m at the respective locations. We're going to do a substitution here. And we should end up with the equation of this line in point slope form. So now what we see is we have y minus y1, which is negative 2. X1 here is a 1. And then we have our slope going in right here. So one bad habit to have is this, is just to put these all in mxy or xym. You have to be careful that y goes here, y1, x1 goes over here, and then the slope goes here. So I want you to put a box around this here. This is, as a matter of fact, the equation of this entire line of solution point, that has this entire line of solution points. But what we wanted to do was to write this in the slope-intercept form. So one habit to get into is this. Once you have this in slope-intercept form, or point slope form, so this is point slope. We had a point, we had a slope, we plugged it in. What we're going to do is simplify both sides. Okay, so we'll start with this. We have y minus a negative 2 is y plus positive 2. On the right side, we can distribute here. We have 3x minus 3. And then what we're going to do is isolate the y value. So to isolate the y value, all we need to do is subtract this 2 here. And what you see is as we combine like terms, we get y equals 3x minus 5, which if you were looking at the same line that I have here, y equals 3x minus 5, we can see a line that definitely has a slope of 3, okay? But also that has a y-intercept of -5. So keep this in your back pocket here. As long as we have a slope and as long as we have a point, we can plug it into this point-slope form of the equation of the line, which is really our slope formula rearranged, and then isolate for y after simplifying both sides there. Cheers.